Now today's lesson is going to be adding and subtracting fractions. For fractions with like denominators, you're going to add or subtract the numerators, and you're going to keep the denominator the same. So if we were adding 3/10 to 1/10, you would add the 3 to the 1 to get 4, and you maintain the tenths. It stays the same. So 3/10 plus 1/10 is 4/10. But 4/10 can be simplified. We can divide both 4 and 10 by 2 to get 2/5. Same is true for a problem like example B. If I'm doing 7/9 minus 4/9, well, we already have a common denominator. The denominators are the same, so I'm allowed to go ahead and subtract. I can take 4 away from 7 because it's 7 minus 4. 7 minus 4 is 3. I keep the 9s the same, so I have 3/9. But 3/9 can be simplified because both 3 and 9 are divisible by 3. So when I divide by 3, I get 1/3. Now, we can also add and subtract fractions using our integer rules. So we can work with, and we will work with, positive and negative fractions. No need to worry though, because the rules remain the same. If I had a problem like 4/9 minus 8/9, then I can think about it as adding the opposite. I could say 4/9 plus negative 8/9. The difference between 4 and 8 is 4. And so then you keep the 9ths the same, and the one with the larger absolute value is the sign you take, so -4 will be your answer. Now, to add or subtract fractions with different denominators, we must rewrite the fractions with a common denominator first. So how do you find a common denominator? Well, there are two ways. The first way is you can find the least common multiple of the denominators. We call this the least common denominator, or LCD. Or you could multiply the denominators to find a common denominator, but it might not be the least common denominator. If we were to look at 1/3 plus 1/6, they are not the same denominator, so we would have to find a common denominator. So to find a least common denominator, you can list out the multiples of the denominators to see what is the smallest number that they share in common, or the smallest multiple that they share in common. If I list out the multiples of 3, I have 3, 6, 9, 12, 15, etc. If I list out the multiples of 6, I have 6, 12, 18, etc. And the smallest multiple that they share in common is 6. So the least common denominator of 1/3 and 1/6 is in fact 6. But if I were to multiply 3 and 6, I would get 18. 18 is not the least common denominator, but if I wanted to work with 18, it would still work. Now, we've already discovered that the least common multiple of 3 and 6 is 6. So in order to use that, we have to follow a few steps. You rewrite the problem using fractions that are equivalent to 1/3 and 1/6, because we want to maintain the value of those fractions, with a denominator of 6, which we already said is our least common denominator. So if I'm adding 1/3 to 1/6, I want to rewrite the fraction problem, the addition problem, with denominators of 6. So I put 6's there first. Now I don't have to change 1/6 because it's already got a denominator of 6, so I can just fill it back in as 1/6. 1/3, however, does need to be changed. Well, what do I do to 3 to get 6? Well, I multiply it by 2, so I have to do the same thing to the numerator in 1/3 to multiply it by 2 to get 2/6. Understand that 2/6 is an equivalent fraction to 1/3, so I haven't changed the value. I've just rewritten it so it can be added to 1/6. So now 2/6 plus 1/6 is 3/6 because I simply add the numerators, and 3/6 is the same as 1/2. So here are just a couple of examples, and this is what my work looks like when I'm all done. I'm going to walk you through it, and then we're going to do one together. So write each answer in simplest form. The first problem that we have is 3/8 plus 5/12. 8 and 12 are not common denominators, so we have to find a common denominator. So I like to find the least common denominator, so I think about the multiples of 8 and the multiples of 12. And my multiples of 8, I can either think of them or write them on my paper, whichever method works best for you. I have 8, 16, 24, etc. When I hit 24, I kind of think, that might work for me because my multiples of 12 are 12, 24, etc. Well, 24 is the smallest number that 8 and 12 share in common as a multiple. So I'm going to use 24. I come down here and I rewrite the problem as blank over 24 plus blank over 24. And then I have to decide what my numerators are going to be to keep the value of 3/8 and 5/12. Well, what do I do to 8 to make it 24? Well, I multiply by 3. So I have to do the same thing to the 3 that's the numerator. And 3 times 3 is 9, so I fill 9 in. What do I do to 12 to get 24? Well, I multiply by 2. Remember that it is multiplication, not addition. Don't say, well, I added 12. No, it's I multiply by 2. So I'm going to multiply 5 by 2 to get 10. Now I just add my numerators. 9 plus 10 is 19. Keep the denominators the same, and I have 24. 19/24 is my solution. I have a note here that says, when rewriting fractions, you multiply the numerator by the same number you multiplied the denominator by to get your common denominator. So, just what I did right here. So example B, I've got 1/10 minus 5/8. Now 10 and 8 are not a common denominator. So I have to think, what would be a common denominator of 10 and 8? I bet you think 80 right away. Now that would be true if you multiplied them and it could work, but is there a least common denominator between 10 and 8? Think about your multiples of 10. 10, 20, 30, 40. I know that 8 times 5 is 40, so I know 40 is the least common denominator of 10 and 8. So I'm going to rewrite my problem as blank over 40 minus blank over 40. 40ths, we're working with 40ths here. So what did I do to 10 to get 40? I multiplied it by 4. And if I multiply 10 by 4 to get 40, then I have to multiply 1 by 4 to keep the value of 1/10. And so 4 40ths is the same thing as 1/10, only with the denominator of a 40. And then what do I multiply 8 by to get 40? Well, I multiply it by 5, so I have to multiply 5 by 5 to get 25. Now I've successfully rewritten my fractions, and now I need to follow through with the operation. Well, this is 4 40ths minus 25 40ths. And I recognize that 25 is a larger number than 4, so I'm not working with integers, but I can consider this an integer operation since when I subtract fractions, I'm simply subtracting the numerators. So 4 minus 25, I can think of as 4 plus a negative 25. The difference between 25 and 4 is 21, and 25 is larger in absolute value, and it's negative, so it's going to come out to be negative 21, and I keep the 40 the same. So my answer is negative 21 40ths. Example C is negative 2/3 plus 5/8. The least common denominator of 2/3 and 5/8. Well, I can think of my multiples of 3, 6, 9, 12, 15, 18, 21, 24. Just so happens this time that the least common denominator between thirds and eighths is going to be the product of 3 and 8, which is 24. And don't forget this negative here. It goes right there. So what did I do to 3 to get 24? Well, I multiplied it by 8. So I multiplied that 2 by 8, and that's 16. And then what do I do to 8 to get 24? Well, I multiplied it by 3, and so I can work with 5 times 3, which is 15. So now it's negative 16 24ths plus 15 24ths. Remember, I keep the denominator the same, so my denominator answer will be 24, But then this is going to be negative 16 plus 15 24ths. Signs are different. Find the difference. Take the sign of the larger number in absolute value. So that's going to be the difference between 16 and 15 is 1. It's going to be negative 1 24ths is the answer. And example D, negative 2/7 plus 1/3. I can tell you that the common denominator is going to be 21, which is what I get when I multiply them. What I do to 7 to get 21, I multiply by 3. And so I have to multiply 2 by 3 to get 6. I multiplied 3 by 7 to get 21, so I multiply 1 by 7. And again, my signs are different. I am adding. And so if the signs are different, find the difference. The difference between 7 and 6 is 1. And I keep it positive because 7 is larger in absolute value and it is positive. So this answer is 1/21.